Welcome to the Core System Technician Training video by Discovery. This is a Core System Technology Training video. In this video we're going to be discussing your personal computer, the hardware that make up your personal computer. Most of it I'm sure you're familiar with. We're including printer, monitor, tower, mouse, keyboard, and speakers. We're going to be discussing the basic terms and concepts and functions of the devices that make up your computer system. We're going to take a look inside your computer tower, and we're going to see the components that make up your computer from the inside, including the CPU, which is a central processing unit. We're going to be talking about the power supply, modem, network card, motherboard, memory, hard drive, floppy drive, and disk drive. So a few key terms that we're going to go over, including some electrical terms. Electricity is what runs your computer system. Without electricity, your computer system would not function. Understanding electricity and how it functions inside of your computer is key to understanding the basics of your computer's operation. The first term we're going to be discussing is amps. And what amps is, it's short for amperage, and it measures the strength of the current of electricity that flows. Ohms, on the other hand, which is spelled OHMS, measures the electrical resistance in a circuit. Watts measures the electrical power in a circuit, and volts measures the electrical pressure in the circuit. In your computer, you've got the power supply, which converts AC current to DC current. AC current is short for alternating current, which is the electrical current that comes out of an outlet from your wall. The DC current, which is short for direct current, is the current that the computer uses. In order to convert and to use electricity from your AC outlet, you need a power supply that converts it into a DC current, so in order for your computer to be able to access the electricity. Now, the difference between AC current and DC current is that AC current is able to flow in both directions, and DC current is only available to flow in one direction. So that's what the difference is between the AC and DC currents. In electricity, we talk about capacitors, diodes, inductors, and resistors. A capacitor is a small component which can hold a charge. A diode is a small component which conducts electricity, but it only conducts it in one direction. We've got an inductor, which generates magnetic fields when electricity is passed through it. And we've got resistors, which resist electrical flow. All these make up the basics of your electrical components within your computer system. One component when dealing with electricity that we should make special note of is the electrostatic discharge, which is short as ESD. And what ESD is, it's the electricity that's generated through static. It's static electricity. And the reason we got to make a special note of this is that even a small bit of electric charge on your fingertips that you might not even be aware of can, if you touch different components within your computer system, you will ruin them through the electrical discharge. And we got to keep in mind that ESD increases significantly under hot and dry conditions. So if you're working on a computer system and the conditions are hot or dry, then you should take extra precaution with your ESD to protect your components from your ESD discharge. There's a few precautions that you can take to prevent some ESD discharge, and the first one is ESD packaging. You should always put your components inside of these anti-static bags or any other ESD packaging form. You can use an ESD strap, which would be grounding you while you're working on your computer system. You can be standing on a conductive mat or using anti-static floor carpets or workbenches. And in the workroom that you're working on with your computer system, it's suggested maybe put in a humidifier and have some control over the temperature. These are just some precautions that you can take to avoid ESD from causing harm to different components. The most sensitive are the memory, the CPU, hard drives, and PC cards. Another one of the basics of computers is how it actually counts. We're used to counting in our regular decimal system 0, 1, 2, 3, 4, and we're based on 10 digits, and then we start again with the 1 again, with the 0, 1, 2, 3, 4 again. So here we've got a little bit of an example of our regular system starts at 1, and we count up, and we see that we're used to seeing this all the time. When the computer communicates, it's communicating either on binary or hexadecimal. And what binary is, it's a series of either ones or zeros. So in order to begin your binary counting, you're starting with a 0, the next one is 1, then after that is 1, 0, 1, 1, and then it's 1, 0, 0. And then we count all the way up. We see that we've got an example here of 16, which is 1, 0, 0, 0, 0. So we're starting both similar as the decimal. We're starting the binary with a 0, then the next one is a 1, but after that the binary doesn't go to 2, it goes to a 1, 0, and then a 1, 1, which is equivalent to 3. And the other form of counting is hexadecimal, and this is based on 16 separate characters, where we're starting with a 1, with a 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's where the similarities with our decimal system end, because our equivalent of 10 is an A in hexadecimal, and then it goes B, C, D, E for 14, F for 15, and 10 or 10 for 16. One of the simplest tools to use to do these conversions in order to convert between the different decimal, binary, and hexadecimal is your own system calculator. And most operating systems come with the system calculator. And this one, we can see that we can enter in a number such as 10. We can change it to binary, which is 1010, and we can also see the hexadecimal, which is simply A. So if it comes to converting a large series of numbers, and we convert it to binary, and we can convert it to hexadecimal. And in turn, we can also enter in a hexadecimal number, and we can convert it to decimal number and binary number, depending on what our preference and how we want to use it. Now we're going to go ahead and take a look inside your typical computer tower, and we're going to first look at the motherboard. We see that it's located in the heart of the computer system, attached to the side of the tower. Depending on the configuration of your computer tower, you might have a flat tower where the motherboard might be sitting on the bottom of it. But looking inside any computer, you should be able to distinguish where the motherboard is, where the hard drive is, where the floppy drive, the disk drive, the power supply, and the modem and the network card are. So we're going to go ahead and look at the motherboard a little bit closely now. We see the motherboard removed from the tower, and we see that there's 3 kinds of motherboards. The original version was the AT motherboard, which was IBM's original version. Then along came the baby AT, which was a smaller version of the AT. And now mostly we're using ATX motherboards, which are a little bit smaller than the AT motherboards and a little bit larger than the baby ATs. We also have 2 different basic types of motherboards. We've got integrated and non-integrated motherboards. Now, an integrated motherboard will have certain components already installed with the chip already installed on the motherboard. Such things as network cards, modems are sometimes integrated into the motherboard and attached to the motherboard. Now there are some disadvantages and some advantages of this. One of the main disadvantages of having an integrated motherboard is that if you've got some problem with one of the components, let's say your network card goes and you've got an integrated motherboard, then in order to fix that, you would either have to replace the whole motherboard, or you'd have to do some work on the motherboard itself, or you could simply purchase another network card and install that. You've also got that choice with the non-integrated motherboard, where you've got components that you can take off and put on that you're able to use interchange as you need to. So when purchasing a motherboard, you've got to look at the disadvantages and advantages. And we can see in this particular example that the motherboard was originally attached to the rear panel. This is a tower case with the rear and the front panel and cover removed. So we had the rear panel here and we had the front panel. We removed that and we were able to access the motherboard. There's also ones where you've got a cover where you can simply slide off the entire rear end of the computer system, depending on what your setup is of the tower and the different makes of the towers. We'll look a little bit more closely at what are the components of a motherboard.